Welcome back again to Practical Numerical Methods for Scientists and Engineer, and we still in Module 4, Roots of a System of Nonlinear Equation, and today we will use MATLAB to determine the roots of nonlinear equation using Newtonian Raphson method. Now, it's not very difficult now, so now as we said, this is our so this is the equation we already used for Newton-Raphson for nonlinear equation. We can rearrange this equation. So we have this here to be inverted, and this one is called Jacobian. So now we can calculate it manually. How to find the Jacobian? Okay, now the Jacobian equal to 1 over matrix determined. So this matrix determined, we can find it. We can find the value of this matrix, and you know how to find the matrix. So to find the matrix, this value times this value minus this value times this value. So the value will be, by this we can find the determinant, 1 over matrix determined times. So here we'll do some rearrangement. Okay, so see, here we invert these two together. Okay, so this one will put it here and this one will put it there. Okay, so it will be the f2 over dx2, and here will be the f1 over dx1. And regarding those, both will keep them in the same position, but we will add minus to each of them. So we just add. So by this we can find the Jacobian, compute the Jacobian of a matrix. Okay, now once we calculate the Jacobian of the matrix, then we just multiply it by f1 f2, so we can easily solve it. Okay, now this example, this is the same previous example. So how can we use it to create the codes for it? So the first thing we can here we can put the x equal 1, 5 and 1.5 and 3.5. So we put here the first equations. Okay, so what will appear will be 1.5 and 3.5. Secondly, we can create the function. Okay, so we can create f x equal x, okay, between parentheses 1 over power 2 plus x 1 between parentheses times x2. So this equation, each one, it will take from the first one and second one. So it will be extract the first value and second value. Okay, and remember here we have the semicolon because we want it as a vertical, and we put the second equation as well. Okay, so this is the second step. And also we need third one, we need to put the Jacobian. So here Jacobian, we can j equal 2 times x, okay, x1 plus x2 comma, this one will be x1, okay, only. Then we can, for the second line, 3x2 square 2 and then 1 plus 6x1 times x2. Okay, so we created the Jacobian. Okay, so here the last thing here we can do, then x equal x minus j slash f. Okay, that's mean, so here actually here we didn't create Jacobian, we put the normal matrix, but because we can use the left division here, so f will be multiplied over j Jacobian, so we could find the solution by this. Okay, so here we can make the insert. Okay, display put input guess for x1 and x2 as a vertical array. Okay, if you don't want to put them as vertical array, the user can put it as any array, but you can put one more step to reshape the array like what we get before. So you can rearrange it to be always to be in vertical. Okay, then f1, we can put f1 the first nonlinear equation. For example, x1, so we put it like this. Okay, f2, insert the second nonlinear equation, for example x1 multiplied x2 like this. Okay, so we put the second equation. Okay, then we want to find the derivative of the first equation. You have to derive it and then put it. Okay, so insert the derivation of the first equation equation to x1. So here we put all the derivation. Okay, and here we put the error and the maximum iteration. In order to do the iteration here, so we start with iteration equals 0, and while 1, that means while all these are correct. Okay, as we said before. Then find f1 and f2. Okay, f1 and f2. Okay, then Jacobian will be J will be df x1 df x2. We already defined each of them here. Okay, then x new will be x minus j left division f. Then we put here the error will be the absolute value of maximum x new minus x over maximum x new. Why we put maximum? Because we found if you have an array, okay, so at least the maximum error should be the minimum than the should be less than that required. Okay, so if iteration equal condition one, okay, then the data. Okay, so from the first iteration, okay, we want to put all the data iteration, comma, for all columns, put iteration, put x1, put x2, and put the error. Okay, and if error smaller than or equal to relative error, then break and else. Otherwise, x equal x new, and then iteration equal iteration plus 1. And if iteration larger than that iteration, okay, then break end, and then display all the data. And then here we put put these codes here just to show it in good or pretty way. Display data. Okay, so it will be here. We put our equations we want, so then our data will be like this. This is iteration number 1 and 2. x1 will be like this, x2 will be like this, and this is the error. So this is MATLAB codes, how to use it, and see you in last tutorial of module 4, how to use Excel to find the roots of nonlinear equation. Assalamu alaikum.